Okay, so we're going to relate, they call them primary trig ratios, to sine and cosine law. So I've kind of defined a lot of, these are all the major trig formulas you're probably going to use in a unit that deals with triangles or solving pieces of triangles. So there's sine law and cosine law, which think of them as like the basis. You can solve absolutely any triangle with these. And then so that should be an A. Let me fix that. So I don't know why I wrote cos. CH katoa. Those are shortcuts for primary trig ratios. There you go. And a primary trig ratio deals with just right angle triangles. What's good about sine law and cosine law is that you can solve absolutely any triangle with them. Obtuse, acute, right angle, it doesn't matter. These are just shortcuts. So what we're going to do here is we're going to zoom as soon as I figure out how to do it. There we go. Oh no. That is not what I wanted. Can I reset? There they are. I knew I had some here. We're going to look at this very first scenario here, okay? If you take a look, it kind of looks like there's only two pieces of information about this triangle, but technically this right angle tells us something. It tells us this angle. In order to solve for any triangle, you need at least three pieces. And anything more than that just makes it really easy. This scenario is the only scenario using a right angle triangle where you can technically use cosine law to solve it. Let's say we're looking for the hypotenuse here, okay? You could technically, you could use your, actually, because you have no other angles here, this becomes tricky, right? You might want to use Pythagorean Theorem first to solve this. That's one way. You do like a squared plus b squared equals c squared because this is the hypotenuse. But we're going to go about using cosine law and just try to relate it to some of the other stuff we're doing. Then we'll go into scenario 2, which will really cover, you can pretty much use sine law to almost solve every scenario with a right angle triangle, right? So the very first one, we'll try putting it through cosine law, and then we'll talk about other ways we could solve stuff here. So this one here, if we're trying to solve this side, we'll call it x. For our cosine law, we're just going to rename that a. So that's going to be our a, which means this is angle a. And that's really important that the right angle is angle a, because there's going to be something really special kind of happening there. And after that, it doesn't really matter. We could call this b, making that opposite corner b, and this c making this opposite corner c. So at a squared, that's our x. So we're going to replace that in the formula. It becomes x squared, I'll get that in red, and actually formula, squared is equal to, b we said is 6.9, 6.9 squared plus side c is 11, so 11 squared minus 2 times 6.9. I'm going to run out of room, but I can just shrink it. 6.9 times 11 times cos, and then cos 90. That's going to become really important here, okay? In fact, we should bring up what cos 90 might be on a calculator. I can bring up decimals and do that in a second. Actually, it's not a bad idea. Let's see if we can get it. Oh, a bunch of YouTube kids and stuff. No, let's get decimals. Oh, there it was. There we go. If we type in, so this can also, it's a graphing calculator, but we can also use it as a regular calculator. If I say cos 90, that's in radians. I need this to be in degrees. Cos 90 is equal to, it tells you right in this line, is equal to 0. Okay, so if you even type that into your calculator, cos 90, you're going to notice that it's also equal to 0. So if that's the case, this part here can actually be replaced with 0. Okay, so let's try that. X squared is equal to, I'm not going to change anything else yet, 6.9 squared plus 11 squared minus 2 times 6.9 times 11 times, that'll be the one thing we change, times 0. Well, 0 is an interesting number. When it gets multiplied by things, it consumes them. It gets rid of them, right? So 0 times 11, 0. 0 times 6.9, 0. 0 times 2, 0. So now we're left with x squared is equal to 6.9 squared plus 11 squared minus 0.
So you couldn't just get rid of it there.
I can just get rid of it there, right? Could have crossed out from thing. Now, this here, do you remember the formula I offhand said we could have used to solve this? Remember Pythagorean's theorem? This is Pythagorean's theorem. So once we know our rules with cosine law and sine law, we realize that we end up just using Pythagorean's theorem. So if you notice right off the bat you could have done it, that's wonderful. It's essentially a squared is equal to b squared. A plus b squared is equal to c squared being the hypotenuse, and x is our hypotenuse in this case. So we can go about solving it. You want to help me out with your calculator there, whatever 6.9 is squared? I'm not quite sure off the top of my head. Just a little under 49, I imagine. 40, not square root. Yeah, squared. And I could do that in decimals, I suppose, too. Let's.
Yeah, 47.6.
Oh, it is 47.6. 6.9 squared. Perfect. 47.6. So we get 47.6 plus 121. Well, x squared is equal to 168.6. And then we're going to find the square root of that. When we bring this over, it becomes a square root. So square root of 168.6. Let's do that together. 168.6. What'd you get?
12.9.
12.98. About 13. X equals 12.98. Let's just say it's approximately 13. So this side is then 13. So if using a right angle triangle, cosine law essentially just becomes Pythagorean's theorem. Okay? It's kind of like a primary trig. It's not technically a ratio, but it's something we could use to solve it. And then from there, once you have that, you wouldn't use cosine law anymore because you have two opposites. And once you have an opposite ratio, the best law to go to is sine law. And then I can use sine law to find my other angles. Okay? Let's go to scenario 2. Can I zoom in? All right. Oh, I like this version. Okay. This one here. I can't quite line up cosine law for this one. Can I line up sine law? What do I need for sine law? I do have 3 pieces of information, angle, angle, and a side. But I need an opposite angle and a side. So I don't have this side, and I don't have this side, and I don't have this angle. Am I stuck? What can I do?
180 subtract.
Yes, so I do actually have this angle, which then means I have an opposite. In any scenario with your primary trig ratios, you're pretty much going to end up with having an opposite somewhere. Since 180 minus 90 is 90, so 180 subtract 90 is 90, subtract 50 is 40. Okay, so this side is actually 40 degrees. So now we can set up our sine law. It doesn't matter what we call things with sine law as long as we're just consistent. So if that's angle A, that's side A. We'll call this angle B, side B, and angle C, side C. So we set up our sine law. Sine A is 40, so we're going to write 40 divided by, that side is 9, is equal to the next ratio of sine B. Well, sine B is actually 90 degrees. Okay. Over to side B is unknown. We're going to say we're trying to solve for side B, okay? And then we'll set up sine C just to make sure we have our information. And sine C is 50 degrees. And the side is also unknown. I mean, we could technically solve for either of them, but we're just going to focus on this set here. The reason I want to focus on it is because of sine 90, okay? Zoom out a little. So we're just going to focus on that. And let's figure out sine 90 if we type it into a calculator. So if I say sine 90 degrees, gives me the value of 1. So sine 90 is equal to 1, which is, again, going to be important to us. I'm going to set it up. Sine 40 over 9 is equal to 1 over b. And b, we can call it x if we really want. Is it easier for you, or is it okay if we call it b?
B's fine.
B's fine? Okay. What's neat about this is I can actually like flip the entire ratio and it's still equal. And I want to do that just so we can start to see how it relates to other things. So I'm actually going to make it 9 over sine 40 is equal to b over 1. And the reason I'm doing that is because any number over 1 is just that number. 1 disappears, okay? So now what we're really working with is 9 over sine 40 is equal to b. And remember in this case, b was the hypotenuse. I'm going to put a little like blue around it just so we remember that that's actually the hypotenuse in this case, okay? I am going to then, I'm going to actually reverse engineer this. It's going to seem a little confusing, but there's a reason, and I'm going to tell you the reason right now. Because SOH, do you remember sine x is equal to opposite over hypotenuse?
Mm-hmm.
Okay, remember that b is a hypotenuse, and that also means that 9, because remember this was our angle, 9 is actually our opposite angle, okay? So I'm going to move some things around. I'm going to move this over here. I'm going to move this b down here. These are I could technically multiply both sides of the equation by sine 40, and then I can divide by b, okay? So when I do that, I end up with 9 over b is equal to sine 40. These two formulas are exactly the same, okay? So even if I don't have my primary trig ratios memorized, as long as I know sine law or cosine law, I can solve all of these. It's really helpful to have SOHCAHTOA memorized because it speeds up the process. There's a lot less calculating. But I have all this. I'm going to actually jump back to here because this is actually the most important part. This was a step that was actually counterintuitive. I just wanted you to show you the relationship. Let's go back to it. We're trying to solve b. b is equal to 9 divided by sine 40. I'll go type that into our calculator to see what we actually get for our hypotenuse. Yeah, you can help me too. That'd be great.
Sine.
9 divided by sine 40 degrees. It's about 14. Is that what you get?
Accidentally.
Ah, okay. I got 14 as a possible answer here. And if we go back to this triangle, 14 is very plausible. This is 50 degrees. This is 40 degrees. 90 will have, it's the hypotenuse. 14 is much larger than 9. So that makes sense. We could verify another time. But what's really important here is I wanted to see the relationship between cosine law and essentially Pythagorean theorem. And sine law is essentially your SOHCAHTOA, your SOA, because you can always find like that opposite ratio and then use sine law to solve for anything else, okay? If you can remember SOHCAHTOA and go through them, that's great, but these two essentially do everything that you need.